We will begin our lecture now on the Kennedy Class 3 removable partial denture. The Kennedy Class 3 and the Kennedy Class 4 are considered tooth-supported removable partial dentures, and they have a different set of rules than what we followed for the Kennedy Class 1 and 2, which were extension-based partials. The definition of the Kennedy Class 3 is a unilaterally edentulous area with natural teeth remaining both anterior and posterior to it. On the cast to the right, the partial denture is the classic definition of the Kennedy Class 3. There's one unilateral edentulous area with teeth remaining anterior and posterior to it. On the cast to the left, we have to think a little bit. We have to think of the following rules and apply several of Applegate's rules to this one. 1. The most posterior edentulous area determines the classification. That would be where the arrow is located, tooth number 18. But we are not going to be replacing the second molar number 18 on this RPD, so it is not considered in the classification. That's a rule. Number 2. So the most posterior edentulous area now becomes the large edentulous area on the patient's right. If we look at that, the cast now fits the definition of the Kennedy Class 3, which is a unilateral edentulous area with teeth remaining anterior and posterior to it. Try and apply any of those other classification definitions and see what you get. They won't fit. Rule 4. Any other edentulous area is referred to as a modification, and they're referred to by the number of them, not by how many teeth are missing. So there are two edentulous areas other than the one that determined the classification. Therefore, this is a Kennedy Class 3 modification 2. Can you figure out what classification this arch is? We are not replacing the third molars on the patient's left side. Which is the most posterior area that determines the classification? It's 19 through 21. Which definition of Kennedy classification does this arch meet? It's a unilateral edentulous area with teeth remaining both anterior and posterior to it. That's our classic definition of the Kennedy Class 3. How many other edentulous areas are there in the arch? There are 2. Therefore, this is a Kennedy Class 3 modification 2. Note that the classification is in Roman numerals. Here we have some additional Kennedy Class 3 partial denture examples. The upper left is a Kennedy Class 3 Mod 1. The modification space is the area with the facings. It has an anterior-posterior palatal bar major connector. Remember that the definition of a bar is that it is less than 8 millimeters in width. I really don't care for the symmetry that well on the anterior part of that major connector on the top left. It may be distracting to the patient. Note also that if you have bars, they must be thicker for strength, whereas the strap, shown on the bottom right, is flatter. Which do you think you would prefer in your mouth? The upper right is a Kennedy Class 3 Mod 1 with an anterior-posterior palatal strap major connector, and the lower is the Kennedy Class 3 Mod 1 with the palatal strap major connector. The only other major connector for the maxillary that we haven't seen up here is the palatal plate. There are several differences between tooth-supported and extension-based removable partial dentures. The Kennedy Class 3 and 4s are the tooth-supported dentures, and the Kennedy Class 1 and 2 have extension bases. We will have a different set of rules for the tooth-supported RPDs than we do for our extension-based RPDs. The differences are in the support, the method of impression, the need for indirect retention, the base material used, direct retainers that are used, and the major connectors. We'll talk about each of these. The tooth-supported removable partial dentures derive all their support from the abutment teeth at each end of the edentulous space. That support is provided by the occlusal rests that are placed next to the edentulous area. The distal extension, also called the extension base RPD, derives its support from the tissues underlying the base and to a limited degree from the abutment teeth. This is referred to as composite support. The Class 3 has no distal extension base that can lift away from the supported tissues. This is because each end of the denture base is secured by a direct retainer on the abutment teeth. A clasp assembly is placed on the tooth at each end of an edentulous space on each side of the arch. You will place the direct retainers so that the retentive tips are as far away from one another as possible. Therefore, it would be the mesiofacial on the anterior abutments and the distobuccal on the posterior abutments. I want you to notice that some of these direct retainers on this example are too short. They should extend to the distofacial of the abutment tooth, not end in the middle of the tooth. Question number 2. From what you can see, which direct retainer arm on the buccal is more flexible? The longer the clasp arm, the more flexible the clasp if all other things are kept equal. Therefore, tooth number 14, direct retainer, would be more flexible. How would you describe the retentive tip of the direct retainer arm on the facial of number 6? It's in the right position on the tooth mesiodistally. It's too mesial. It's too distal. The answer is that it is too distal. That direct retainer arm should extend to the mesiofacial surface of that tooth. The Kennedy Class 3 has 2 fulcrum lines. The first one is through the 2 anterior abutments, and the second one is through the 2 posterior abutments. The partial denture could, depending on the forces on the prosthetic teeth, try to lift up and rotate around that anterior fulcrum, or it could try to lift up against that posterior fulcrum. But this is prohibited from happening by the presence of a clasping mechanism on each abutment next to the edentulous area. So we have 4 clasp assemblies on the Kennedy Class 3 next to the edentulous areas. We do not have to worry about torque forces being applied to those abutment teeth in the tooth-supported RPD because of these clasping mechanisms. The cast circumferential is the clasp of choice in the Kennedy Class 3. Here's an up-close picture of the cast circumferential clasp, or we sometimes call it the cast C, and it is the direct retainer of choice. It is placed at each end of the edentulous area. We can use rigid clasping because this is a totally tooth-supported prosthesis. We don't worry about torque forces. A rest is placed on the abutment tooth next to or near each edentulous space. This is an example of a framework that has been waxed on the refractory cast and is about ready to cast into a framework. A rest is placed on the abutment tooth next to the anterior edentulous area, even though we do not clasp those 2 teeth. We only have 4 clasps on a Kennedy Class 3 partial denture framework. We can rest the tooth without placing a clasp assembly on that tooth, but we have to have rest next to each edentulous area. Question 4. Does this follow the rule about rest placement? Yes or no? Well, it does. We do not place rest on weak lateral incisors on the maxillary arch. On the mandibular, we don't place them on centrals or laterals. On this maxillary, we could have placed one on the central incisor, if the occlusion is not a factor or not a problem. We have gone over to the two canines and plated the remaining natural teeth. This would provide adequate support by using those two canines to support those two facings that are in the area of the central and the lateral. It's very common for us to move over to the canine and use them for support. The palatal strap is usually used when the edentulous spaces are in the posterior and are short span edentulous areas. This can make for a very nice little partial. Remember that a palatal strap is a minimum of 8 millimeters in width. The nice thing about it is that it can be very thin and be kind of hidden up there, not too noticeable. Here's another example of the palatal strap major connector. Notice the difference in the width of the strap compared to the lower right design. They used plating in conjunction with the cingulum rest and went farther anterior with the strap. They had two options on this design. One would be to plate all of the anteriors to get from one canine to the other with the major connector, or to dip down around the four laterals. The tongue goes to the anterior behind those incisors to make certain sounds, as an example, the S, CH, J, and TH sounds. The anterior border, when dipping down like this, should be positioned in the valley between the rugae and positioned so that the border becomes confluent with the tissue and that border is not noticed. And it must avoid the speech zone as much as possible. It also must avoid, according to the rules, the marginal gingiva by a minimum of 5 to 6 millimeters on the maxillary arch and 3 to 4 millimeters on the mandibular arch. The anterior-posterior palatal strap major connector is common and may be used with any Kennedy classification. The hole must be at least the size of a nickel if you place one. You want to expose the patient's tissues as much as possible so long as you do not jeopardize the strength of the prosthesis. The anterior strap must be a minimum of 8 to 10 millimeters, the posterior strap a minimum of 8 millimeters, and the side borders should be 7 to 9 millimeters. If you make the dimensions smaller, then the laboratory will bulk up the areas to make them thicker, and it will be more noticeable to the patient. The manner in which the class 1 and 2 distal extension is supported often necessitates the use of base material that can be relined due to tissue change that will occur as the ridge resorbs. The acrylic base can be easily relined. The class 3-2 supported prosthesis does not require rebasing or relining of those prosthetic areas, except when the area is unhygienic, anesthetic, or uncomfortable to the patient. This is because no torquing forces are exerted on the abutments. Metal bases may be used more frequently in the tooth-borne RPD. This is an example of a tube tooth which has metal as the base resting above the tissues. This may be an aesthetic issue on the maxillary arch. If bone resorption takes place in this area, you may have a black open area at the tissue surface of the tube tooth. And if the patient has a high smile line, then this would be an anesthetic area that cannot be relined. You may say to yourself, well, look at that, there's metal anyway showing up there. The tube tooth can be designed where the acrylic tooth butts up to the ridge and no metal shows. This should be done on a maxillary tube tooth. When you do this type of tooth replacement, you should also give ample healing time, 10 to 12 weeks, in the area of the edentulous space before you take your final impression for the framework. Another one of the differences between the Kennedy Class 3 and 4 from the Kennedy Class extension-based designs, which are the 1 and 2, is the method of impression making. The Kennedy Class 3 does not require an impression of the functional form. This will be explained later when we talk about altered cast procedure, which is performed on extension-based areas of the Kennedy Class 1 and 2. We are going to begin to talk about the survey and design of the Kennedy Class 3 cast. We need to know our goal for the exercise, but we need to know a definition before continuing. The path of placement is the direction a prosthesis moves from the point of initial contact to its terminal resting position. It is the point where all rests are seated and the denture bases are in contact with the tissues. One of the objectives of surveying a cast is to determine the most acceptable path of placement that will eliminate or minimize interferences to the placement and removal of the RPD. Another objective is to identify proximal surfaces that are or can be made parallel so that they act as guiding planes during placement and removal of the prosthesis. We want to position that cast so that we have the least amount of tooth structure that has to be removed in order to create this parallelism. Here are examples of what the guide plate and guide plane look like. Ideally, we prepare a 2 to 3 millimeter flat surface on each proximal surface of the abutment teeth. Metal will contact these flat surfaces and will guide the prosthesis into final position. This will help to create stability of the partial. There's also a 4 millimeter area below the prepared guide plane where the plate will not touch the tooth. The undercut begins here, and the laboratory technician will block the space when constructing a partial. The metal guide plate cannot go into the undercut as the guide plate does not flex. The space created here will allow food and debris to be able to escape without driving it into the sulcus during placement of the partial. The top left picture kind of exhibits this pretty well. By surveying bony prominences, we wish to determine whether tooth or bony areas of interference will need to be eliminated either by extraction, surgery, or by selecting a different path of placement. By surveying the dramatic bony contour on the lingual here, we know that we cannot go below that with our flange, or food will get up and under the overhang that we create. An important objective is to locate and measure the areas of the teeth that may be used for retention. Retentive areas must exist for a given path of placement on all the abutments and must be contacted by retentive arms that are forced to flex over a convex surface during placement. To continue on with our objectives, we must locate the height of contour on the abutment teeth and to locate areas of undesirable tooth undercut that are to be avoided, eliminated, or blocked out by the laboratory technician. Surveying permits an accurate charting of the mouth so that we can do mouth preparation. For instance, the proximal surfaces must be prepared for guide planes, and that survey line needs to be at least 3 millimeters below that marginal ridge. Our surveyor indicates and shows us what we have to do to achieve that purpose on those teeth. Also, excessive contours are eliminated to allow the proper placement of direct retainers and reciprocal components. On this molar, we are possibly placing a direct retainer to the distolingual surface. The first 2/3 of that direct retainer must be all above survey line, so it is necessary that we lower that survey line so that we can place the first 2/3 of that retainer all above the survey line and ideally in the middle third of the tooth. With the use of the surveyor, we will record the cast position in relation to the selected path of draw for our future reference and for the laboratory technician. This is called tripoding the cast. It's done by locating 3 marks in red that are on the same plane of the cast, and then we circle those marks in blue. There are indications for the use of a facing as a tooth replacement. They are large bony undercuts, a deep vertical bite, when spacing is a problem in the arch, for single tooth replacements in the anterior, when aesthetics is a concern, when the ridge loss is not extensive, and we don't have a long span. We have 6 or less teeth. We'll talk about each one of these. A facing contraindication would be a large bony defect like you see in the car accident case on the lower picture. A facing would look extremely long, as you see above. You may need to create a gingiva effect when the patient has a high smile line. This is shown in the prosthesis above. This will produce a nice natural look when the patient has a tendency to show the gingiva when she smiles. If you have a span greater than 6 teeth, you would use base rather than facings. You need the additional stability afforded you with the base on the prosthesis. Since you cannot reline facings, if you anticipate a change in the bony structures with time, you would not use them. If you choose to use the facing, then you should wait at least 3 months after extractions or any oral surgery for shrinkage of bone before making the final impression for the facing prosthesis. This is an example of a facing indication that involves a large bony undercut in the anterior. If you use a flange, it would have to stand out away from the tissues when you seat the prosthesis completely. The path of draw for the other teeth may be at a straight 90-degree angle to the occlusal plane, but the flange may not if you want it to be close to the tissues. The flange must seat at the same path of draw. The flange also would add additional bulk in an area that's already naturally pretty prominent on this patient. You might say, well, okay, let's just get rid of the bone in that area and make the flange less prominent. When you do that, though, you're creating a larger lever arm anteriorly compared to the mandibular teeth, and the teeth would have to slant posteriorly at the cervical to reach the bone, and this would be very unaesthetic. What if the patient decides to do implants at the time of treatment planning and you have already removed the bone? Think before you jump in and act. You may regret a quick, make it easy on yourself decision. Totally work up the treatment plan and the case before making any decisions. The end goal should be determined before you start working. Look at this deep vertical bite. Is there room between the maxillary and mandibular for a layer of acrylic to sit on top of the ridge, for base attachment to be on top of that to hold the acrylic onto the partial denture, and for another layer of acrylic on top of the base attachment for strength and to add teeth? No way. We need at least 4 to 5 millimeters for that. But there is room for metal backing of the facing to go through that area and to become confluent with the major connector, with a little bit of enamelplasty possibly on those mandibular teeth. With a little luck, maybe they've extruded slightly if there have been no opposing teeth to hold them into position for a period of time. So the deep vertical bite is an indication for the facing. When you look at this case, you have quite a bit of space between the canine and the central in which to place prosthetic teeth. It is too large of a space for a central and a lateral. They would be quite small in relation to the existing teeth. If we try to put one large tooth into that space, it would look like a huge shovel next to that other central incisor. So a facing may come in handy when we have a spacing problem and we want to maybe leave a little diastema between the teeth. Also, one single tooth on base attachment would not be very strong. We would be apt to leave it into that meatball hoagie the next time we go to that restaurant with hard bread. It's often helpful to have a diagnostic wax-up to show the patient what it would look like. Or, if you're handy with a computer, you may take some pictures and a little Photoshop can do wonders like it did in this case. One of the most common repairs that comes into the dental office is for that single denture tooth that has broken off the patient's prosthesis. Therefore, if you have a single anterior tooth edentulous space, you must plan for added strength in that area. One of the solutions is to place a facing in that area. I think it would also be safe to say that if you had two small incisors missing next to one another on the mandible, like number 24 and 25, then facings would be a good choice in that area because of the small space. When aesthetics is an issue, the facing does look like it's emerging out of the soft tissues. If the tooth has a slant posteriorly at the cervical, though, you may lose some of your aesthetic advantages, depending on how much bone's been lost there. This is an unusual case because if you really look closely, you will see that the edentulous space had just centrals and laterals missing. The canines are there. The patient did not want diastemas in that area and has a very high smile line. So we placed 6 anteriors from canine to canine in that space. So she has 2 canines, but she loved it. The ridge loss cannot be extensive for use of the facing, or the tooth will have to be very long, or you will have black holes in the gingival area. This isn't necessarily a problem if you don't have a high smile line. If you have black holes, though, air will escape between this area when speaking and can be annoying to the patient. The cervicals of the teeth must be at approximately the same height as the natural teeth at the gingival margin, or it will be unesthetic as a result. The facing allows us to keep the buccal or the facial cusp at a height equal to the remaining teeth, even though the bite may be very deep, because it is backed with metal that prevents the cusp from breaking off. This is the lingual view of that patient where we replaced the 4 incisors with the 6 anterior teeth. 6 teeth are the limit as far as the number of teeth that can be missing and replaced with facings. Note that the facing has a buccal or a facial surface that is white, but the occlusal surface is in metal as shown on the premolars number 4 and 5 and on the canine on the opposing side. So if we're doing an aesthetic case and we're doing premolars, the tube tooth would be more aesthetic because it has an occlusal surface that is white as compared to the facing. Here we have the reinforced acrylic Pontic, or wrap. It has metal incorporated into the denture tooth, and then acrylic is added to cover the metal areas. It has many of the same indications as the facing. It is probably more aesthetic than the facing as it has less metal show-through at the incisal area. The metal has a tendency to make the facing appear gray in that area. There is less tooth supported by metal backing, which may not be a factor unless you have a very deep bite and have a significant amount of denture tooth with unsupported metal. There could be a greater chance of the cusp breaking off, but the tooth is held very securely in the framework with the metal struts. A tube tooth can be used for a single tooth edentulous space in the anterior, so long as there's no deep vertical overbite present. It is also indicated for a single posterior tooth, where you want aesthetics. Notice that the occlusal of the posterior tube tooth is white acrylic versus the facing, which has a metal occlusal. The tube tooth has a nail head that comes up through the hollowed-out denture tooth for retention, and the tooth is luted onto the framework with resin, composite, or cement. It is only as good as its retentive mechanism in the framework. The lack of retention in the example on the bottom right was the reason for this metal-based partial denture's failure. You may have vertical space that is slightly reduced because the part of the tube tooth that sits on the ridge is solid metal, which requires less space than base attachment, but it also means that it cannot be relined if bone resorption occurs under it. Both the facing and the tube tooth must be fabricated on a mounted set of models for accurate occlusion. The area should be well healed before the master impression is made. This is an example of the tube tooth used in the anterior. It may be used for a single tooth replacement to give added strength and retention to the prosthetic tooth. A deep vertical overbite is a contraindication to its use. Other options for the single-tooth anterior replacement might be the reinforced acrylic Pontic, the facing, or the braided post. Which one is best depends upon occlusion, and sometimes it's just personal preference. A tube tooth usually is a replacement in a single posterior edentulous space where you want the aesthetics over the metal tooth or the facing replacement. You will usually not find more than two tube teeth together. This lower left framework is a very complicated and expensive framework. The laboratory charges you for each tube tooth, facing, or other special replacement, other than base attachment. So make certain that you know the laboratory fee before you begin your treatment plan. A tube tooth is possibly indicated where you have a vertical space that's reduced. The exception would be where the buccal cusp would be much shorter than the teeth on either side of the replacement teeth. Then you may need a facing where you can keep the buccal cusp much longer, reduce the lingual cusp for occlusion, and keep the tooth protected from breaking off. The metal backing on the tooth protects the buccal cusp from breaking. The contraindications for the tube tooth are: you have a deep vertical overbite that interferes with occlusion. B, if you think a reline is needed in the future, then another replacement method should be chosen. And C, if the width of the edentulous space is insufficient for the nail head that retains the prosthetic tooth, plus the tooth to be luted in place over that retentive component. If it's insufficient, then another method has to be chosen. The braided post has similar indications as the tube tooth. In its construction, it may be placed on base attachment, which allows for relining the prosthesis if resorption takes place under it. It's constructed by twisting a rope of wax, which gives the braid design and creates retention for the tooth. It is used in the anterior or posterior area for reinforcement of a prosthetic tooth or retention of the prosthetic tooth. The metal tooth is indicated when you have a small space between abutments and there is insufficient room to place the retentive mechanism for the tube tooth or the braided post tooth. It is indicated when you do not have enough space for an aesthetic facing, or when there's not enough room for a tooth to be placed in base attachment. The metal tooth is waxed into the framework wax pattern, and a full mounted set of casts is necessary to fabricate it. A metal tooth may be indicated when you have a larger space in the posterior and there is no concern about aesthetics. It can be fabricated into the framework when the opposing occlusion is metal occlusion. It is used when you want a strong replacement tooth. Which tooth replacement shown in the picture is used when you have an aesthetic conscious patient? A, the tube tooth, B, the facing, C, the metal tooth. This one, pretty obvious. The tube tooth, which has an occlusal in resin, would be the one of choice. Here's a little quiz for you. What replacement tooth shown in the picture is used when you have a full gold crown opposing the replacement tooth area shown on those slides? The answer is a facing. When you have metal opposing metal, you will get better results. If you have metal opposing acrylic, the weaker of the two surfaces wears more rapidly. This page shows a few of the survey and design rules, which tell you to use certain colors of pencils for certain items on the survey and design of the cast. The items that you will need are these ones in color, plus the lead pencil, and the next slide will also give you some of the things that you need to do this exercise. The items you will need to do the cast seminars are the surveyor, the table, the surveyor tools, perioprobe, a cleoid discoid, red, blue, brown, and lead pencils, a millimeter ruler, a cast eraser, and your thinking cap, the most important thing. Spare lead is usually on the supply benches in the laboratories. I have some suggestions. Go to youtube.com and search for my channel under Ann Winchie. Review the survey and design seminar tapes for the Kennedy Class 3 maxillary and mandibular cast. There are 2 casts with 4 tapes each. Print the screen forms that are shown on the next 3 slides and actually do the drawings with the designs and with the tapes. It will make you aware of all the rules for proper placement of the component parts of the partial denture, and you will gain skill in being able to draw these designs yourself. Do a screen copy on this. If you don't have a program for it, you can get a little free download called Grab It, which makes it very easy, and print this screen. Use it in the seminars. Print this screen for the mandibular cast of the Kennedy Class 3 seminar. Print this tentative design sheet to be used with the Part C tapes for all the survey and design seminars.